want you to scratch out this problem and please write the limit as x goes to infinity of 2x minus 1 over x plus 1. On your last test, you were told to be able to look at this example and to be able to determine that limit algebraically. Do you remember how you determine that limit algebraically? You did. And before we do that, let's actually look at, suppose we were to plug in a large number for x. Would everybody agree that in this situation, you would get infinity divided by infinity? And that's problematic. It's not undefined. It's what we call an indeterminate value. Kind of like how earlier this year we came up with 0 over 0. We learned how to deal with that. We found it to not be that big of a deal. I want to show you a new way of handling this, and it's a way that I think you're really going to like. You used to take out the x, and when you did, you had 2 minus 1 over x times 1 plus 1 over x. And as x went to infinity, these terms went to 0. Those crossed off, and you're left with 2. Now, here's what I want you to understand. Suppose instead of looking at this as one function, suppose we looked at it as a function on the top called f. Do you know what the graph of 2x minus 1 looks like? Yeah, we do. It looks something like that. Agreed? We'll call that f. And then we have this other one called, say, g. And you know what that graph looks like, right? Okay. And the question is, what happens as we divide them? Well, look at each function in itself. You see that f is headed to infinity and g is headed to infinity, right? And that's why we get this infinity over infinity piece. Which one's headed to infinity more quickly? Everybody agree it's headed more quickly? How much more quickly is it headed to infinity? Twice as fast, right? The slope is 2. And so this guy by the name of LHospital, as you can see here, this is the name. He came up with a rule for dealing with indeterminate values. And it's a really, really beautiful thing. When you look at a derivative, or when you look at a limit that's headed to infinity like this, or even 0, and you end up with what we call an indeterminate form, you can simply take the derivative of the top and the derivative of the bottom. Watch. What's the derivative of 2x minus 1? 2. What's the derivative of x plus 1? 1. LHospital's rule comes up with some amazing ways to deal with very, very difficult limits. It's really useful. Here's the conditions that we must have. The limit as x approaches something of a function over a function. If that's equal to infinity over infinity or to 0 over 0, if you get what we call an indeterminate form, again, it's called an indeterminate form, then you may do this. The limit as x goes to whatever of f prime of x divided by g prime of x. So there's just one caveat that you have to make sure you do. Check ahead of time that you either get infinity over infinity or 0 over 0. And if you get that, then you can use LHospital's rule. Let's look at one of the examples. You can see how nicely it works. The limit as x goes to 1 of natural log of x over 1 minus x. First, we start by plugging in 1. And we get the natural log of 1 over 1 minus 1. Natural log of 1, that means e to what power gives you 1? E to the 0 power gives you 1. Everybody agreed? So therefore, we get 0 on the top and 0 on the bottom. Indeterminate form. Let's use LHospital's rule. So we do the limit as x goes to 1 of, what's the derivative of natural log of x? 1 over x. What's the derivative of 1 minus x? Negative 1. Now we try plugging in 1 again. When you plug in 1 again, we get negative 1. It's a beautiful way to deal with very complicated examples. Look at the next one. This is the limit as x goes to infinity of e to the x over x squared. I plug in infinity, and I get e to the infinity power over infinity squared, which is really just infinity over infinity. Agreed? Oh no, what do? L'Hopital's rule. Limit as x goes to infinity of, what's the derivative of the top? E to the x. What's the derivative of the bottom? 2x. I plug in infinity. You get infinity over infinity. Oh no. What do you think I do? Do it again. Limit as x goes to infinity of, the derivative of the top is e to the x over 2. And I get infinity over 2, which is infinity. Is that nice? The next one. I again get infinity over infinity. Natural log does tend towards to infinity. Think of the graph. The graph looks like that, right? It tends very slowly to infinity, but it does go there. And the cube root of x, that looks like this. And that does tend towards infinity too. It takes a while to get there, but it does tend towards infinity. So therefore, I need to take the derivative of the top and the derivative of the bottom. Fortunately, you're very good at your algebra. How do I take the derivative of the top? Natural log of u and 2x. Derivative of 2x, 2. Derivative of natural log of u. So you're going to get 2 over 2x, which is, so I have the limit as x goes to infinity of 1 over x over, now I need the derivative of x to the 1/3. Derivative of x to the 1/3. Everybody agree? 1 over 3x to the 2/3. 1 over 3x to the 2/3. Oh no, I have a complex fraction. What do? And after I cry, I will multiply by the reciprocal. I get 3x to the 2/3 over 1. So what do I end up with in the numerator? I get 3 on top, and on the bottom, this is x to 1 in the denominator, so x to the 1/3 in the denominator. As I plug in infinity now, what's going to happen to the top? It's just 3. What's going to happen to the bottom? It's going to go to infinity, and that result will give me 0. We're just going to do 3 more and let you guys work. This becomes rather challenging here. Give me a second. I need to look at it. Okay. I intended for this problem to work out a certain way, and it did not. So please rewrite it like that. I forgot to change it in the notes that it looks like. So instead of cosine, we're going to go sine. I plug in 1. What's the natural log of 1? Again, that means e to what power is 1? 0. And so I get 0 on the top, and in the bottom, the sine of pi. So if you think of your coordinates, you have this coordinate right here. The coordinate is -1, 0. What's the sine value? It is 0. So I get 0 over 0, which is an issue. So I'm going to now invoke the rule of L'Hopital, which is take the derivative of the top. How would I go about taking the derivative of this top guy? What is the outer structure? U squared, and the inner structure is natural log of x. Derivative of u squared is, and derivative of natural log is. So would you agree that I get 2 natural log of x over x? So I have the limit as x goes to 1 of 2 natural log of x over x. Over, and on the denominator, how do I do the derivative of sine of pi x? I do use the chain rule, sine of u and pi x. What is the derivative of sine? And the derivative of pi x is pi. So I get pi cosine of pi x. I plug in 1. What is the natural log of 1? That means e to what power is 1? So I get 0 over 1 divided by, does anybody know what the, so I have pi times 1, which is pi. Anybody know the cosine of pi? Negative 1 times pi. So I get negative pi in the denominator. So what is 0 divided by negative pi? 0. Please look at this example that we just had because it's going to really help us here. If I plug in pi, what was the sine of pi? 0. And as you consider this, what's the cosine of pi? What's 1 minus negative 1? 2. So did we get an indeterminate form? So you do not apply L'Hopital's rule. So we just have 0. That's the answer. So please make sure that you check before you automatically do L'Hopital's rule. Tenley, wonderful human being. Last night she had a problem with her math. She was doing 484 minus 480. You see, they were doing subtraction of 3-digit numbers. And so she had, this type of problem where they're learning how to borrow. Everybody agreed? You understand? You understand why it's important, right? So she went through the process here, and then she went through the process here. And after she did, I said, Tenley, it's just 484 minus 480. It's like, oh, it's just 4. I'm like, right. And I understand why you continue to go through it. Because, she continued to put zeros and wonder if she had to borrow. I'm like, at some point you got to step back and say, just, come on, see, she got used to the process, right? That's my warning to you. Don't get used to the process. Consider what it might be ahead of time. Got it? Last example. I plug in 1. And as I plug in 1, what do you get in the top? 0 divided by 0. Oh no. Use L'Hopital's rule. Limit as x goes to 1. What is the derivative of the top? 5 times 14 would be 70. So you take 14 times 10 and divide it by 2, right? That's the same as multiplying by 5. 70x to the 4th over 24x cubed. Now, remember, just plug it in and see what you get. If I plug it in, I get 70 over 24, right? Divide both sides, or divide top and divide by 2, you get 35 over 12. So 35/12 is your answer. So L'Hopital's rule takes some complicated limits and makes them super easy. It's a gift given to us. You didn't learn anything necessarily new today, other than just checking to see if it's an indeterminate form. Then go ahead and take your derivatives.